In order to explain where some of this stuff comes from, it's good to give a bit of historical context, as well as some other names for what we're talking about here. For one, well, rectangular coordinates isn't the only thing that we call this system, even though, in my opinion, it's the cleanest in terms of being able to describe what you're actually looking at in terms of, well, what it looks like. One of the other names, one of the best known ones that's used for this, is the Cartesian coordinate system. It's called the Cartesian coordinate system in recognition of the man who originally designed it. Well, originally is a bit of a strong word, but the man who's given credit for it, René Descartes, who, when he wasn't busy looking like he should be chasing Peter Pan or making us question the nature of our very existence, was actually best known for his work in a field that would become analytic geometry in the 17th century in France. In particular, in his time working on La Géométrie. As I know, French philosophers, they tend to be a little bit presumptive with their naming conventions. He designed what would become what we call, at least in this class, the rectangular coordinate scheme in terms of those x and y values. But some very natural questions do occur when you see that scheme, and in particular the notation there. For one, are there other ways that we can talk about position? The answer to that is yes. We're not going to see it too much in this class, but for another example, there's an idea called polar coordinates that you'll probably get developed if you go on to take pre-calculus and beyond. But otherwise, another big question is, well, series of questions really is why? That is, why is horizontal x? Why is vertical y? Why do you write x, y? When we're going to talk about equations and later functions, why is x in some sense the important one? Why is it not flipped around? Why don't we call these, I don't know, zeta and tau? Why don't we give them some other name? Why did they get that name in particular? And one apocryphal answer for that is that when the copyists were working on copies of Descartes' work, La Géométrie, they decided that, well, we're looking at all those equations, they want the values for the formulas and the pictures to really stand out. They want them to pop against all the text on the book, because the pictures are what really are going to draw people's attention. So they picked a letter that doesn't appear very often in French. They picked X for talking about the horizontal one, the one that is in terms of most of our functions that we'll see later. It's a nice story. It's a somewhat believable story, but according to most current evidence, it's probably not actually a true story. The reason why it's probably not true is because, for one, before that sort of thing was concerned, before this idea was developed, Descartes was still using that notation. He was still using those x values, and there's reason to believe that the idea of x values dates back to the Greeks with a symbol that they used, chi, that looks, well, strikingly similar to an x. But some even argue that it dates back further, like a lot of our notation, that it comes from the Middle East and India with their own ideas. But the point is, we actually don't have a great fixed answer for why it is that x is the center of our mathematical universe, other than you, obviously, because you're the origin in that other video. But actually, even though the story is likely apocryphal, likely not true, that idea of x being in there because it looks good and because it's convenient actually is a bit illuminative on the general idea, on the general thought about where a lot of our notation here can and often does come from. For a comparison, it's a bit more linguistic, a bit different from all the numbers we're going to see later. Think about what I'm holding in my hand here. Hopefully, everyone who's watching this video is looking at this and wondering, why are you holding a pipe? And those of you who think, why are you holding a pipe? They'll probably get the answer that, yeah, that looks like a pipe. Isn't it a pipe? Although maybe some of you who are feeling particularly clever and snarky and know a little bit about surrealism might have something else in mind. Ceci n'est pas un tuyau. ceci de un video de un tuyo. But regardless of what your answer is for what this thing is, generally speaking, when we're talking about something like this, we call it a pipe. But is its pipeness obvious, self-evident, entirely definable, and definitely true no matter what? No, of course it isn't. For one, in that other part, when I was speaking in French, I didn't say pipe. The French don't call it a pipe, and if the French aren't sure about something that's this basic, who could we possibly trust at all?
À savoir que le langage, ça n'a jamais, ça ne donne jamais, ça ne permet jamais de formuler que des choses qui ont 3, 4, 5, 10, 25 sens. Le sujet supposé savoir.
We don't call this a pipe because it must be a pipe and it can't be anything else. We call this a pipe so that if someone comes up to you and says, hey, put that in your pipe and smoke it, for one, you're going to be offended, and two, you know that this probably wasn't what they meant. Point is, though, that when it comes to naming, when it comes to notation, when it comes to all this stuff, a lot of it comes down to what we happen to like in the moment, what might look good, and failing all that, a little bit of intuition, I suppose, a little bit of luck and just random chance that we end up where we were. Because the truth is, that doesn't have to be X, that doesn't have to be Y. If you really wanted to switch that around, you could make that one X and that one Y. Or you could call that one fish and that one cat, as long as you knew that when you're making functions in terms of fish, you should be getting cats. Which is weird. That's why you don't do that. But you could. In the same way that took the alphabet, there's nothing that says the alphabet has to be A, B, C, D, and so on. And for some time, if you look up the history, it wasn't. There were other things in there, and there weren't always that order, but we like the mnemonic, we like the song, and we need to give some organization to that, because it's 26 things. How can we be trusted to remember all of those without something? It's too much. But at a certain point, that's what happens. Someone smart came up with that idea, and when they told their students about it, they said, hey, this made sense to me. And if they were good teachers, then their students said, oh, okay, that makes sense to me too. And then when their students were teaching their students, years and years down the line, they said, well, this is how it works. And the student said, okay, I guess that's how it works. And if that stuff was really at all clever or even remotely useful, that's how it stuck. That's how languages evolve all the time, and math is a language. It's a funky language, but it is a language. So when we use these terms X and Y, it's not because it has some great specific meaning, it's because, well, we need to call them something and we need to be consistent. Those are the most important features of a language, or consistency and predictability, so that if I show this to you, or I show a pipe to someone, they don't wonder what it is, they know what I'm talking about. And just a quick side note, every now and then in this class I will try to provide some context and some history for where some things come from. Usually I'll try to have more satisfying answers than this, but every now and then, well, cigar is just a cigar, notation is just notation.
That's your answer?
Yeah.
That's not right. I mean, there's a right answer here, but that's not it.
But anyway, that's enough philosophy for now. The next thing I want to talk about is back to a little bit more of that math, a little bit more of those actual ideas we were seeing there with graphing and in particular equations.